Yes. Yes, done.
Good afternoon, students. Today we are going to study about the root locus method. So before going to the topic, root locus method, I would like to some questions to you people. I think your name is Vikas. Do you know about the open loop system and the closed loop system?
Yes, in closed loop system there is feedback, but in open loop system there is direct input and output with a gate in between.
Okay, that's good. So here is the learning outcomes that after studying this the root locus technique, you people will be able to draw a root locus for a given transfer function, and the most important things, you will be able to check whether the given system is stable or not. Till now we have studied about the stability, and the stability from the transfer function concept. And just preceding to this chapter, we have studied about the Revolves criteria. In the Revolves criteria, what we saw that according to the placement of the poles, according to the position of the poles, how the system is stable or unstable. Is that? Now, moving next, we are going towards the system gain, the impact of the system gain on the stability of a system. So in this lecture, we will see that not only the placement of the poles or the position of poles have impact on the stability of the system, but also there is very much impact of the system gain on the stability of the system. So see, now root locus. So what is root locus? As you said, we see root locus. What is root locus? It is a locus, and locus of the root. Locus of the root is known as the root locus. Now we know the locus. Locus is not a fixed point or a predefined a straight line or any curve. It is a variation of the output or a curve with respect to the any input given value. So what is root locus? Root locus is the locus of the root based upon the variation of the system gain k. So with root locus we will study about we will judge on the stability, steady state error, okay, and the relative error. One more thing, in the Revolves criteria or in the time domain analysis method, whatever we have dealt with the closed loop transfer function. But here in this system, what we are going to do, that we are going to check the position of the closed loop poles based upon the open loop poles. Okay? So here we will draw root locus from the open loop poles, and the result is that with that we can judge the final position about the closed loop poles. So see, here you can see a transfer function. Here you can see a system. Okay, there is a closed loop system. Here this is the input. Here this is the system gain k, and here this is the open loop system, open loop transfer function of the system. And here we are giving the input feedback to the input. So see, this is known as the open loop gain of the system, and that is represented by the GSHS. So now we will move towards the drawing of root locus. How we can draw the root locus for a given transfer function, rather we should say from the given open loop transfer function. If the open loop transfer function is given, then okay. If it is not that okay, if it is not given, then as I talked in the time domain analysis concept, we can find the open loop transfer function from the given closed loop transfer function. So see, this is a transfer function. This is the open loop transfer function. Gs, Hs, this is equal to 1 by s plus 1 into s plus 2. So from this system, we can find the position of the open loop poles, and the open loop poles is equal to, by making this the denominator of this open loop transfer function is equal to 0. So from here we can see it has 3 poles, one at the 0 position, second one at the -1, and third one at the -2. So see, there are some rules to find the root locus for a given transfer function. The rule 1, locate poles and zeros. Here in this system there is no zeros, only poles is there. So we have located the 3 poles, 1, 2 and 3. Then second, each branch of the root locus originates from the open loop pole and terminates at the open loop zeros. So here, since there is no open loop zeros, okay, so there are 3 open loop poles, so 3 branches of root locus will be there, and it will originate from the given 3 open loop poles, from here, here and here. Now on the real axis, the root loci exist only to the left of an odd number of poles of zeros. So with the given graph, when we plot the positions of the poles in 0, then we can take a particular point, and we can see that to the right of that, how many total number of poles and zeros are there. So suppose we are taking here this point. So right to that there is a one pole. So one pole, it means from here to where the root locus will be exist. But when we are crossing this point, then we can say that the right to that point there is a even number of sum of the poles and zeros. So between this section, the root locus will not exist. Now we will calculate the breakaway point. What is the breakaway point? As I mentioned that in the certain section root locus will exist, and certain sections root locus will not exist. So the position where the root locus will exist, here it is at 0 and -1. Okay, so in this section there is a section of the root locus. Also I mentioned that it originates from the poles and terminates at the zeros or infinity. Since there is no zero, so all the poles, all the root locus, the 3 sections of the root locus will terminate at the infinity. So here one it will originate from here, another it will originate from here. So it will come somehow something like this. It will originate from here, it will originate from here. In this section, entire section, there is no part of the root locus. Again, there is another pole -2. So again, the third pole is here. So again, there is another sections of the root locus. So for this particular root locus, those particular section of the locus, there is no program, because it originates from here and it will terminate up to infinity. So it will go along that path. But here, since it is coming from here, this also coming from here, so there will be a certain point where it will break. The sections of the root locus will break and it will go to infinity. How it will go to infinity? So to guide that curve, the locus of the root, there is a point known as the breakaway point. How can we calculate the breakaway point? We can calculate the breakaway point like real parts of equals minus real parts of 0. By this method we can calculate the breakaway point. Okay, and here by this method we can calculate the angle of the asymptotes. So here we have calculated the breakaway point, and out of the two, here we find the two breakaway point, but only one will be valid, another will not valid, because this breakaway point is not coming on the root locus. It is coming at minus 1.577, but here there is no path of the root locus, so it will not